Now off to division. First, let's talk a little bit about vocab, what you call the different numbers in a division problem. And I'm going to write out a division problem in multiple ways, and then we'll talk about what we would call those numbers. So one way is to use this symbol. That symbol means divide by. So we might have something like 24 divided by 8, okay? And the answer to this problem is going to be 3. Okay, we're taking 24 things and we're going to group them in, we're going to make 8 groups of them, and we want to know how many items are going to be in each of the 8 groups. And so 3 would be in those. And a good way to double check your division is to use the inverse operation. Take excuse me, your divisor and your answer and multiply them together, and that should give you your original number. Okay, and that's going to be the case. 8 times 3 is 24. So in this case, we're using this division sign. Another way to write it out is using this symbol here, and the first number that was written over here is going to go underneath. The second would be on the outside. So it's going to look like this. So, you know, we think, well, 8 doesn't go into 2, but it does go into 24 3 times, because 3 times 8 is 24. Okay, so that's another way, a second way that you can show division. A third way is with like a backsplash or backslash. So it looks like this: 24 8. So backslash 8. Having a hard time saying that. But this means division, and it looks kind of like a sideways fraction, but it is a division problem. And you know, normally if you see something like this, it might be easier to just rewrite it as this. The first number again goes under the division sign, and then this bottom number or last number goes on the outside, and then you would solve. The last one would look more like a fraction. So 24 over 8, it does look like a fraction, like an improper fraction, which we'll talk about fractions here soon. But this is also considered a division problem. We're asking how many times does 8 go into 24, and the answer is going to be 3. So these are different ways that we can show division. Now let's talk about the vocab. Okay, so this first number, this 24, and I'll circle the 24 in all of the cases, that is called the dividend. So 24 is the dividend. Okay. The next one, let's use pink. That's it. So that's the 8. The 8 in all of these cases, that's called the divisor. And the last is the answer to all of these problems. The 3 is going to be the quotient. Okay, so if it helps to make a little cheat sheet here, I'm going to put dividend under here, divisor, and quotient. You can also write it as a fraction or with a backslash. We'll do dividend, divisor equals the quotient, or dividend on top, divisor on the bottom. Divisor equals the quotient. Okay? So those are little, just little helpful hints on how you want to organize your division problems. Let's go ahead and solve some division problems, or go through the process of doing problems where you actually have to write it out and do a little calculating. So I'm going to first divide, and I'm going to write it out one way and then write it out another way. You're most likely going to find problems looking like this, where you're given a number and it's asking you to divide by another number. Okay, so 9,380 divided by 7. Remember, this is the dividend, so we want to rewrite that as underneath the division sign. Also, I want to note that this is a comma, it's not a decimal point, and so you don't need to put the comma up here unless the answer has more than 3 digits. The comma is only used to kind of break it up so it's visually easier to see, but it is different than a decimal point. All right, so we're basically saying I have 9,380 of something, and you can imagine whatever that thing is, maybe it's dollars, and I want to break that up into 7 groups. So imagine I have this amount of money and I have 7 people that I've got to divide the money into these 7 groups, so each person in the group gets a fair share. So each group is going to get the same amount, and that's what we're figuring out here in this problem. So to begin, we're going to start from this, the far left position, and we're going to basically say to ourselves, how many times does 7 go into this first number? And in this case, it does go into the 9. It goes in 1 time. So 7 times 1 is going to be 7. Now it doesn't exactly go or fit the 9, but so we want to pick a number that's either equal to the 9 or the number given, or just below that number. Okay, so that's 7 goes in 1 time. So 1 times 7 is 7. I'm going to subtract to see what the difference is, and I get 2. Now I know I'm on the right track because the 2 is less than 7. If after subtracting I came up with a number larger than 7, like 8, then I could pick another number up here, like a 2 instead of a 1. Now what we'll do, and I'll use a different color, is we're going to bring down the next digit. Okay, now we're saying to ourselves, how many times does 7 go into 23? Well, if you're thinking 3, you're right, because 3 times 7 is 21. And so I'm going to go ahead and write that and then subtract and find the difference. So I find out that I've got 2 left. Again, I want to bring down the 8. Okay, so how many times does 7 go into 28? It goes in 4 times. In fact, 7 times 4 is 28. And so when I find the difference, I get 0. But notice here, I still have another number, okay? And if I were to bring that down, I'd have 0. 7 goes into 0 0 times. And so instead of stopping here at the 4, I need to put a 0 there, because that is the end of my number. And so, my decimal point would be here. Normally we don't put a decimal point after the last digit, especially if we're not working with decimal numbers. But I want to make sure I go to the very end of this number. So because I had that open space, this is kind of like a space holder. So this would be my answer, 1,340. So each person in that group would get $1,340. That's pretty good. That would be a nice gift. Now, let me just show you that if if you're not sure of your math, you can certainly go back and check your work. But another way to check is to take your answer and the divisor and multiply them together. So I'm going to go ahead and do that, and hopefully we get this answer here. But let's go ahead and see. So we've got 1,340 times 7, and so that's going to be 0. 7 times 4 is 28. Carry the 2. 7 times 3 is 21. Plus 2 is 23. Carry the 2. 7 times 1 is 7. Plus 2 is 9. 9,380. And that's what we started out with. So I really feel confident that this is the right answer. When you're doing multiplication, or excuse me, if you're doing division, it's really a good idea to do this process here. Plus, it gives you additional practice for multiplication. Same with if you're multiplying, you could divide your answer and get one of the factors. And so those inverse operations really come in handy. Let's do a couple of more problems. All right, so we're moving on. Let's say we have 1,872, and we're going to divide by 18. All right, this one might be a little trickier, but let's see what we can come up with. So I'm going to rewrite it. 1,872 divided by 18. All right, now this is a 2-digit number, and so again, the process is, you're going to start at the far left and then work your way in until you find a number that this 18 will go into. Now 18 is much bigger than 1, so really this is this first place here we would leave empty, or if it's helpful, you could put a 0. Honestly, I would just leave it though. So, but right now I'm just showing you there's nothing there. 18 does not go into 1. But now let's look at 18. Well, 18 goes into 18 one time, because 1 times 18 is 18. Okay, and then the difference, of course, is going to be 0. Now we want to bring down that 7. So we're thinking, does 18 go into 7? No, it doesn't. 18 is much bigger than 7. So we have to put a 0 here, because 7 is not big enough to hold the 18. So what we'll do now is bring down the 2. Okay, now we're thinking, how many times does 18 go into 72? And you might not, maybe you don't know offhand, so you need to do a little guess and check on the side, and that's often the case with a lot of division problems. And so I'm just going to do a little estimating first. If I round this to the nearest 10, that'd be 20, and if I round this to the nearest 10, that'd be 70. And 10 or 20 goes into 70 at least 3 times. That'd be 60. So I'm just going to do a little guess here and do some multiplication. 18 times 3. That's going to be 4, 24. 3 plus 2 is 5. So 54. That's pretty small. Let's see about 18 times 4. Maybe it's one more. Or it might even be 2 more. But let's just try one more. So 18 times 4, that's going to be 32. 4 plus 3 is 7. Oh my goodness, it's the exact one. I thought maybe we'd have to go again. So 4 times 18 will give us the 72, so I'm going to write that 4 minus 72 is 0 is left. So notice I had the 0, 1, 0, 4. We don't write this out as our final answer. The answer would be 104. So if we were to take 1,872, divide that into 18 groups, each group would have 104. Okay, so say you had, I don't know, boxes. This was the number of boxes, and then we wanted to group the boxes, 18 groups of boxes. Each group would have this many boxes. Okay? And let's see, there is one other way I wanted to show you how to do division. And let's say, let me get an example here real quick. All right, let's say we had 6,750 divided by 5. Now this method is called the partial quotients method. And again, if you have a child in primary education right now, or probably not primary, like 5th or 6th grade, they might be learning it this way as well as the standard algorithm. But, you know, if you find this way easier, there's no reason why you can't use it, because it works. So again, I'm gonna go ahead and set it up, but my division sign is gonna look a little different. It's kind of gonna go down, kind of like a hangman. And this dividend will again go under here, and then the divisors on the outside. And what we're going to do is we're going to write our factors on the right here. Okay, so and we're going to use numbers that we feel comfortable using, that we know by heart, like tens, hundreds, thousands. So instead of looking at this 6, we're going to look at the whole number. Okay. So 6,750, and I have 5. How many times would I have to multiply 5 to get, you know, something close to that? Well, I know 5,000 is close to that. And 5,000 is 5 times 1,000. So if I put 1,000 here, and then multiply 5 times 1,000, that gives me 5,000. Then I can subtract. Okay, and now I've kind of broken it down. So now I'm going to keep doing that. I'm going to think about, well, what is an easy number that I can multiply to 5 that I can think of, you know, right off the top of my head, so I don't have to do any of this business here. Just make it a little quicker. You know, maybe, you know, I know 1,500, if I multiply that by let's see, 300 would be 1,500, so 300. And if you're not sure about that, you can take 300 times 5. That's going to be 0, 0, 15. Okay, so I'm going to then put the 1,500 here, or 1,500. Subtract, and I get 250. Well, I know 5 times 5 is 25, so 5 times 50 is going to be 250. This is a good method if you've got your multiplication facts down, especially the tens, hundreds, you know, thousands. You know, when you've got multiples of 10. It makes it really easy for this one. Now, you've got these numbers here, so what you would do is you would just add them up. and then you would have your final answer. So we've got 1,350. And if you wanted to do it the standard way, we can just quickly do that. We've got 6,750 divided by 5. And again, we start here, so that's going to be 1. Subtract the 5, we get 1 left. Bring down the 7. 5 goes into 17 3 times, because 3 times 5 is 15. Subtract, we get 2. Bring down the 5. 5 goes into 25 5 times, and that's going to be exactly 5 times. And then we bring down the 0. We've got to put a 0 here because this is the last digit in our number. And sure enough, we get the same answer. Okay. Honestly, this is what most of you were taught, but some people really have a hard time with working in this direction instead of seeing the whole number. So if you would rather try it this way will work, and if you feel more comfortable doing it that way, I'm fine with that. Okay, so that's a little review of division, and I think we're done here.